See if this thing works. Don't know if it's working. It worked. Huh. This is really weird. New way of doing everything always. Okay. Did I leave? I left with a thing undone last time, didn't I? Or did I? Let me go back through the... Wait. Did I finish that? Oh, I had an error there. That's right. I think. So yeah, so let's see if we can fix that. Oh yeah, let's do that. We gotta get, let's see. I need kind of thinking like this. You got a different keyboard, so it acts funny. I don't like the new keyboard. I may have to get rid of it. All right. Okay, so what's a good word? One that I hadn't used before. Oh no, that's a lot of letters. Okay, if you'll tell me how to spell it, we'll use it. Okay, give me a second. Let me get there. C-A-T-E-R-E-I. E-I? P-I. Oh, P-I. P-I-L-L-A-R. Is that really right? It looks different.
C-A-T-E-R-P-I-L-L-A-R.
That's it. So is that... Did I spell it right? Is that spelled right?
Yeah.
You know what? Sometimes you look at a word, it's spelled right, it just doesn't look right to you. Now, I don't know why. It's just human nature, I guess. At least it's my nature. I don't know. Okay, so there it was. So what I did, I goofed up on this problem. Let's see if I can ungoof up on the problem. So the first thing I goofed up on, looks like to me, I think that was a different number. I think. Gosh, now I'm going to have to go find it. Let's see. It was... Okay. Let's see, I didn't, wait, is it 103? Yeah, 103. I did not go after this angle, so that I didn't worry about. But he says 130 kilonewtons, and the moment is 10.1. So I'll tell you what, instead of doing it this way, here's what I'll do. It's not working, but why is it doing this? Here. Do the delete button. Everything's always weird. Alright. Now, let's see. Is that the right button? Okay. 103. But you know what? 102 is in there too. Okay, so I'm doing that just so I can put it somewhere so I don't have to go back forward. Oh gosh, it's really big print. Oh. Okay, well wait a minute. Maybe I did okay. Okay. Because he's saying 130 and I got 129. But what about the moment? Okay, where did my moment go? Okay, I got a moment of that, and he got a moment of this. So let's see if we can resolve the moment. I think my resultant's okay. Okay, so let's see if I can resolve my moment, if that makes sense. Okay, so I go back to what I did. And it looks like to me I did them in individual chunks. So there's my 4 individual chunks. So the first thing I probably should have done, and I did not do, is I should have designated in the moment what I was going to consider positive. Now, I always try my best to do that. That looks funny. So here, I like to do that as far as my moments go. I always pick that. If I don't, you're free will to fix me on that. So, so now let's go through each individual thing. So I got this is this force. It should be 2 meters away. Okay, and it is going in that positive direction, like so. Now I connected this to the tech mail, so I'm gonna get. I don't know how to stop those postings from popping up. Shoot, why did I do that? Anyway, sorry if these post up. They're gonna be in the videos. Shoot, I'm gonna have to figure out how to fix that because that might be a problem. So now let me go to the next one, which is 300 is this 7 apart. I got 7. Okay, so then the next one is the 562.92, 10 away. So that's 10 all the way to 562. Now, I might want to double check this, because if I can see that if I rounded numbers too much here, and I multiply it times 10, it's going to be a significant part of this. So, in light of that, oh, I tried to hit octave. Now, I looked away when I did it. Did I get it? Oh, no. Okay, at least I got one of them up there. So the key is it's 30 degrees, it's 650. So let's try it again. 650 times the cosine in degrees, that's 30 degrees. 562.92. Okay, and then I got 1500. And that 1500 just is a couple, and it just basically adds to it. So then the next thing, did I add these correctly? This number and these two all together. And on that, I guess I'll go to octave again. Oh, okay. I guess it popped down there. So 433.1 times 2. Now, if you look at all of them are the same sign. So plus 7 times 300 plus the 592, no, sorry, 62.92 times 10, and then tack on that $1,500. I mean, $1,500. 15. Oh, it is that. Somehow I added it wrong. I don't know what I did. Okay, so my addition, you got me. I don't know what I did. So the number actually, the MB I do not know why, but it just. So 1095, which is effectively that. So somehow I messed that up. Now, if you look at 102, he wants to know the replace the load with. Okay, let me read it. Replace the load system acting on the post, which I guess that's the post. It's a beam to me, with equivalent resulting force in couple at point A. Now the force is going to be the same. So what you notice is the force itself, I didn't find that 80 degrees. I don't feel like doing that. So I just found it in components. So the force itself is the same. Now let's look at the moment. Okay, that's what he's got there. So what you do there is you just, what's the moment at A? And I'll go ahead and use the same sign convention. So what I'll do is just systematically go through it. Okay, first of all, this one doesn't give you any moment because it's going right through A. This one is still, it's 1500. Now this one goes this way. So it's going in a positive sense, and it's going 562.92 because that's its value. But this time it's 3 over to it. So it's times 3. This time you have this one, which is going this way. Okay, so I'm getting this too much stuff on. This one is going the other way. So it is a minus, and it is the 433, and its moment arm is 5. 433.1, moment arm of 5, and that's all I got right there. And so, bring up the calculator. No? Yeah. Whoop. So this time it's 1500 plus 562.90, and I think my finger slipped. 92 times 3, and then minus 433.1 times 5. 1023. Is it 2 or 3? 3. So there's your moment at A. And that's what he got right there. Now I'm going to add another tricky thing that he doesn't add. And what I'm going to add is, and here I'm going to try to do this. See if I can I just copy that picture? Yeah. And then I'm going to go right down here. And now, I guess I could call this whatever number or something. He has numbers here, but this is a new question. The new question is related to this, and it's not any of this, but say this is going to be equal to something else. But what I'm going to do is I'm going to do this. Okay, let's see. Take this. This is a standard thing to do, so even though I'm doing this, it may look odd, but you take this. Okay, so now you have this. And I'm going to say, hey, drop it about right there. And for some reason, it's a little bigger than the other one, so I'm going to shrink it back to its equivalent size. And what I'm going to do, I'm going to have to sort of trick this thing a little bit. Here's how I'm going to trick it. I'm going to say, I guess I could have got rid of that, but here. Now you've got this with no load. But I want to find the location that would have a load here, and have a load here, which I guess this will be a new spot, C, where FC of X, FC of Y, and there is no moment. So what I'm doing is I'm trying to find an equivalent load here that I could put that would have no moment. So now that I've done that, I've got to draw that C back over here. So what I'm going to do is put a point C, say right here. And now what I'm going to do is I'm going to work the problem here and show it back here. So now it turns out the sum of the forces in the X are basically, let me say it like this. The forces, the FC, you noticed, here, let me go up here. You noticed the force, resultant force, did not change no matter what. Only the moment changed, and since his is organized, reference his, the moment changed based upon where I moved the resultant force. But the resultant force didn't change. So if you look at what I've got, let me sort of see if I can diagnose it here. I got the FBX of 75. And then I got the FBY kind of referencing here to this. So let's see if I can go down and write this equal 75, and up here it equals to 1296. That's solved. The question is, where does point C sit? So what I'll do is I'll say the moment at point C, and what I really want, I'll say this, it to be 0. So I'm going to put I'm going to kind of highlight that because that's part of the problem statement, so to speak. But I don't know where it's at. So I'm just going to say it's some distance X over here. So now I'll just take off and do that. 1500, that comes from that thing. Now, oh shoot, well I'm going to have to put put this back. And I'm going to have to put this one back. I think this was 433.1, and this was 562.9, I think. Wasn't it? 562.92, and then 433.1. There is a component going this way, but it doesn't produce a moment about C. And there's also one going this way, but since it lines directly up with C, it doesn't produce a moment about it. So all I've got is that. And then I've got this one. This one produces a moment this way about C. And it is 562.9 times 3 plus X, which I do not know, which that's what I'm trying to find. And then this one goes this way. So it goes the other way, meaning it's minus 433.1 times, now the distance is 5 minus X. This is 5 minus X. And so that's the X2 I'm looking for. So I get 0 is equal to 1500 plus, oh gee, that and that. Okay, so I guess I'll sort of see if I can bring back, not that. Yeah, I want to bring back the calculator. Okay. So let me bring the keyboard over so I can watch while I'm typing. Okay, 562.9 times 3. 1688.7 plus 562.9x. Let me make sure I did that right. 569.2 times 3. Okay, now I got to do the next one. Sorry for my handwriting there. Okay, so the next one is 433.1 times 5. Huh? That's weird. Okay, 433.1 times 5. 2165. Okay, now I've already forgot that number. Oh boy. 2165.5 plus 433.1x. So what this means is I got to gather this one together with this one. Plus and a plus gives me a minus. I'm sorry, minus and a minus gives me a plus. And then I take this, minus that, move it to the other side, and so I get 2165.5 minus 1500 minus 1688.7 divided by, now, if I took these three, if I took this one, and this one across, and I left this one and this one over on the right hand side, the ones that are blue change signs, the ones that are green do not, and then both of those are positive anyway. 562.9 plus 433.1 and 2165.5 minus 1500 minus 1688.7 divided by 62.9 plus 433.1 gets about, minus 1.02, which means my point is on the other side. So that means my point is actually over here instead of over here. So I could basically say this is 1.02. So essentially placing these loads over here, just like that, these two are exactly equivalent. So believe it or not, sounds weird, but if you put a load out here right at C, you'd get the same results as you would if you did all this stuff. So I don't know if that makes sense, but I wanted to add that to it, because sometimes he asks you for that. As a matter of fact, let me go find, I know there's one problem that he does ask. Oh, but it's not, okay, wait a minute. Let me see if I can find it. Is that where it is? Okay, so there's one that's, let me try to find it first. And it's a fairly simple one. No, it jumped around. Okay. No. Where was that one that he had? You know what? It may have been in a different edition of the book. Okay. Or maybe it wasn't. Maybe it was in this section. Okay, so let's see. Where was that problem? Wasn't that one? Wait, was this one it? No. Place the load 100%. That one looks familiar. That might be a different version of the same one. Replace the load on the frame by a single resultant force. Specify where the line of action intersects the vertical line. Yeah, this is a different drawing, but it's the same question. So let's do that one. What time is it? We might, even if I don't have time to complete it, you know, I can just save it up there and we can continue it. So the drawing is a little bit different than I remember, but I remember, you know, these are old memories. But we did do something like this before. Okay, so how do I add a page in between there? There we go. I really need to start splitting this notebook up because it's just a hodgepodge. Okay, so he says, replace the load on the frame by a single resultant force. Okay, and he says specify where the line of action intersects the vertical line at, oh, wait a minute, AB, measured from A. So you know what? I think I'm going to have to copy it again, and I'm going to copy it this way. Okay, new. I'm going to copy it without the forces here. Okay. And then what I'll do is sort of drop it right there. Okay. This time it made the same. So he's saying that in effect, somewhere, I'm just going to make up a spot. You're going to have this. He didn't designate it, but I'm going to, since this is C and this is B, I'm going to call this location D, X. This is F, D, Y. So he's saying the same. He wants these to be the same. Well, there's 2-3 ways you can do this. One is work off of this drawing and designate, he says, measured from A. So he's wanting to know this. So you can start with this. How about we do Y? We'll just call it Y, because I don't know anything else to call it. So what I'm going to do is, I just want to move the keyboard out of the way. And I guess that's sort of lined up. So what I'll do is I'll say, okay, I got a spot. I didn't, oh yeah, I did. I called it D. Got a spot D, and I want this, I'm going to basically say, I got this spot D. Well, first I'll find this. These are easy. So, you know, look at the force in the X. Okay, it's only 600. What's the force in the Y? Actually, I kind of drew it the wrong direction. So here's what I'm going to do. It kind of goes down. And then what I'm going to do, I'll just do the magic of this method. I'll just say that, and then what I'll do, I'll say, let's see, 400, and then 200, and then another 200. I think that's about 800. So there, I got that part. That was the easy part. Got the equivalent force, and I got the 800, which is 4, and then another 4, so that's 8. So we got that part. That was easy. Now what I've got here is I got a location D, which I'll designate it over here too. And this distance Y, and the moment at D, because I want it that way. How about that for a reason? Because I'm going to make it equal to 0 because I want it that way. And it's kind of like I'm picking Y so that that is going to be that way. So it's not, I have to vary Y around so that D changes so that it is that way. I don't know if that makes sense. So what I'm going to do, oops, what happened there? So I'll just start it off. Well, you know, I can move Y up and down all I want. It's not going to change the moment that occurs because of these two forces. So they're going to be the same. So I guess I really need to put a designation all time. So I always do it that way. So this is going the other way, and this one's going the other way. So hang on. So it's 400, this force times this moment arm. Oops. And the moment arm was half. That took care of that one. But now I got 200. That is a whole meter away. Now the key is this one. If I move this point D up more and more, if I move it to right there, just take a case in point, and move it to right there, then this doesn't produce a moment and that doesn't. Well, these two moments are still producing a moment this way, so it can't be at the top. You've got to start moving it down somewhere. So as you move it further and further down, what happens is the 600 is producing a moment that way. And that is negative as well. How weird. Okay, so wait a minute. Okay, that's okay. We'll see if we can get this. Did I see that right? Okay. So let me, sometimes that's difficult to see. Clockwise, so okay, so what I'm doing, counterclockwise is negative. Clockwise, and clockwise. It's positive. So I have a feeling that from what I'm seeing, that this Y point is going to be up here. So it's okay. Minus 600 times this distance, which is going to be 5. And I'm just going to, this is going to be weird. So you know what I'm going to do? I'm going to call this Y tilde. Okay. So if I move this across, and I want to find Y tilde, and Y tilde would be, okay, so the way I should look at it is Y tilde is in that direction. So if I get a minus, it's the upwards direction. So Y tilde would be, okay, I'd bring this to the other side. And I'm making it 0 because I want it that way. So I move it over, and then I get a plus on the far side. So I get 600, and then a minus, let's see, half of 400, I think is 200. And the same thing here. So 2 and 2 is 4, so 4/6 or 2/3. Now, I really feel weird about this because I think you know, we'll just see. Okay, so this is 119. Should be very close to that last one. Static, 119. Yeah, because this is where I was last time. What? Did I misinterpret the whole question? Place a load, or replace the load on the frame by a single resultant force. Specify where its line of action intersects at a vertical line along member AB. Okay. Now let's go back to what it has, and let's see if I'm, okay, do I have the right number? 4119. 4119. Tell you what, let me do this. I don't see that he actually answered the question. Okay. It's okay. Yeah, I'm going to select 419 as well, because that doesn't make sense. Okay, so this is his answer to that problem. Okay. Now you tell me. To me, that number is the same as that number. Am I right? That's right, right? Okay. Now, first of all, his number of 1,000. That makes sense because if you look at 600 squared plus 800 squared, that's going to be 1,000 because of that 345 thing. Okay, hang on. Let me prove that to you. But to do that, I got to get here. So if you take the square root of 600 squared plus 800 squared. Did I do the square root? Yeah. So you get 1,000. Okay, I buy into that. Now, he's saying theta is equal 53 degrees. Now, here's what I think he's saying. Although this is not what he asked, that's okay. Oh, I should have drawn this a little bit different. So he's saying, here's your 600, here's your 800. Now, he's saying this, I'm assuming this is related to that angle, which would be that angle. So if this is 1,000, then the cosine inverse of 600 over 1,000 would be, let's check that. I'm getting to the point where, okay, arc, cosine, degree of 600 divided by 1,000 is 53.13. 53.13. Okay. All right. I'm okay with that, even though to me, why? I don't know. He didn't ask for it. Distance 2.17 meter. Distance from what? Oh, distance from the bottom. Okay. So he's saying truly is, what is the distance? So I found this to be 2/3 in the opposite direction. So if you add 1.5 plus 2/3 equal to 1.5 plus 2/3, 2.166, 2.1667. Okay, all right. Now, yeah. Now let me repeat this to see if I'm making sense. So again, because I misinterpreted, although I think about it a little bit differently than he did. He's wanting to know the distance specified where the line of action intersects the vertical line along this. So if it's up here, and it's like that with a 600 and an 800, then he wants to know this distance. What I did in mine is I designated this as being, I assumed it to be down here mistakenly. I kept with that. I found that it was minus 2/3, meaning that it was this way. It was 2/3, and then 1.5, and the 2/3 add up to be this. But he never asked for that specifically, but that was part of his deal. So when I saw that, I immediately was looking for a number and a distance. I was not looking for that, and so this threw me off. I was, if you're going to put it back there, put it in the problem statement so that you're supposed to find it. But anyway, I managed to do that quicker than I thought, but at the same time, okay, so I don't know. I'm apprehensive about starting another one, but I could. Go away. I don't know. Maybe what I'll do, I guess next time what I'll do is I'll pull out the ones that are in the problem set, and I'll pull them off the web, and I'll drop them in there, the homework set. And actually, I've been busy doing, advising and all these other assignments I've got, but because I'm doing it because no one else can do them. So I've gotten a little bit behind, but I think what I'm going to start doing is posting, you're going to start to see it in emails, probably near the end of the week, that'll have assessment of everybody's grade. That's not just for this class, that's for the other two as well. So it'll be like, the way it'll say it is kind of different, so you can't be scared. So if it says you got an F, it's basically saying if you walk away today, you don't do anything else, you got an F. But then it'll say, here's your grades to this point. It'll tell you how many points is in each one. And so all you got to do is go take that midterm, or what I listed is either a midterm or a test one. They're both the same thing. And the final and the test two is the same thing. So I need to rechange those names to make them consistent. But in the email you'll receive, I guess I'll say test one or midterm, and put it in some two, and then say test two, principal final. You do it that way so that people don't get confused. I thought I was going to do something different and rechange the names of things, but it turns out, I kind of find out that there's no reason to change things sometimes. So all you have to do in this course, and I probably should make it more rigorous, but I'll save that for the fall. And I'm not going to all of a sudden change everything, because that's a pain, so I'll just change it slowly. I've had to change things dramatically since, I guess, what was it? Wasn't last spring. Wait, was it? No. 2020. Oh, God. So I'm still, I mean, I adapted rather quickly because I already knew how to do this and stuff. But I'm gonna find it very not appealing to adapt back. Because, I mean, I think if I can produce the lecture this way, not stream it, everybody can find it, even if you miss something in class, you go back to the thing later and rewind it and look at it, you know, so I'm not adapting back.
So you're not doing similar for dynamic?
Yeah. The only thing I could see different would be, I'll say this, but I'm not going to commit to it, and that is that I might regroup the problems and say, here's chapter, this set of problems is test one for chapter whatever. But it'd be about the same amount as just making it in the midterm. So I don't know if I'm going to do that, because if you really think about it, why do that? If there's a whole set of problems that are in chapter this, and they go together and you call them test one, why would you split the problems if you're doing them this way? It's a fruitless task. Why do that? I mean, just put them together and clump them and say this is test one. And then if it's test one, why don't you just name it for midterm? What difference does it? Test name it maybe. I mean, if it's the same percentage. So I may just do the same exact way, you know? It works. I've had moderate success with it. I don't know what that means, but, you know, I don't know. So I'm probably just going to stick with this thing. I may make slight adaptations, but I'm not sure I'm going to do much changes at all. So unless y'all, you know, I'll quiz you guys. I'll actually put a questionnaire out and see what people think about how, you know, I mean, I know we have these review things at the end of the semester. Those things are junk. But what may be more informative to me is if you know, if I get direct feedback and say, oh, okay, you know. So, but if it works, it works. But, all right. So now